This is an overview of everything you need to know about complex integration. A complex integral has three components: f of z, dz, and gamma. F of z is a complex function of a complex variable z, u plus iv. dz is a complex differential, dx plus I dy. And gamma is a contour on the z-plane from z1 to z2. A contour is a path of a moving object such that it cannot stop more than finitely many times. There are two cases. Either we know that f of z has an antiderivative, or we don't know, or it doesn't exist, the antiderivative. If the antiderivative does exist and we know what it is, all we have to do, evaluate it at the endpoints, the final minus initial. This is the case where little f is derivative of capital F. So little f has an antiderivative. Now, the other case where we don't know the antiderivative or the antiderivative doesn't exist. In that case, we parameterize the curve or the contour. So we find a parameterization z equals z of t, where t is between a and b. So in other words, at time a, the object is here. At time b, the object is there. And then dz is the velocity of z prime, or the derivative, times dt. After the substitution into the integral turns into this, which has a real part and the imaginary part, and both are just ordinary calculus integrations, which we can deal with easily. So there are two cases. The antiderivative doesn't exist, or we don't know it. In that case, we reduce it to this by using a parameterization for gamma. And the other case is when the antiderivative exists and we know what it is, we evaluate it at the final point minus at the initial point. We will prove this fundamental theorem of calculus next.